exponential today. But I want to review. I'm only going to do one of the methods because it'll be more focused on what we're doing today. But there were two ways that we've done in Algebra 1 and earlier this year in your summer assignment to write the equation of a line, y equals mx plus b, through 2 points. The one was using point-slope form. That's the one I'm going to skip for now because it's useful. I like it better. I think it's faster than solve for b, but solve for b is similar, more similar to what we're going to do. So if you are a 10th grader and took geometry at Hayes last year, this is the method that the geometry teachers at Hayes use. If you're a 9th grader, you had Mr. Bricker last year, he likes this method, solve for b. And everyone's probably done this. So let's review it real quick. Make it fast.
Can I move real quick? There's too many heads and turns in here.
Yes. You wanted to sit by Joe.
I'm going to just go be lonely.
Yeah, go be an island.
Hi, friends. What's up?
Alright, so this is the format of the line that we want to get to. Y equals mx plus b. What is the m standing for? Slope, and the b is the y-intercept. So, do I have the slope? No, that's my first step. I need to calculate the slope. So I'm going to write m equals. Now, when I write the slope, I need to know my x's and my y's. Which y do you want to start with? 6. Okay, so we like this point better. So I'm going to write 6. Now, is the slope formula plus or minus the other y? Minus the other y, so 2 negatives there, minus -3. And then what do I write first? Which x? 4 minus -8. All right. What is 6 minus -3? 9 over, does that simplify? Yes. It's 3 over 4. Okay. That's good. I have the slope. I have the m. I don't have the b, the y-intercept. Does anyone remember what I have to do next? What do you do, Meg? Alright, so I'm going to plug in the x and the y here for one of my points. We're going to use 4 and 6. And my slope. So for y, I'm going to put the 6 equals, what was my slope? 3/4 times that x value, which is 4, plus b. And then I'm just going to simplify. What's 3/4 times 4? It's not 4. Oh, it is the end of a week for sure. It's 3. Plus b. Alright, good recovery, good recovery. Alright, now I'm going to subtract the 3, and what's my starting value? 3. Okay, so if I know 3 is my y-intercept, and 3/4 is my slope, what is my equation of this line? Alright, that's your answer. Not hard, right? Now, I only did this because it's a similar process to what we're going to do in a few minutes, but we're not in the linear unit. We are in the exponentials and logarithmic unit, so we're going to focus now on exponentials. Here's what you did yesterday. Real quick, let's review an exponential. We looked at an exponential equation and we identified parts of it. What's the y-intercept for the first equation? 3. This starting value is the first number you see. That's the y-intercept of your equation. What is its growth rate? 2/5. Now, that growth rate is less than 1. So is that exponential increase or decrease? Decrease. All right. Next one here, similar. What's the y-intercept? 12. What's its growth rate? Okay. And increase or decrease? Increase, because 1.74 is greater than 1. So those two should be easy. We should be able to look at an equation and identify its parts. When I look at this third one, I'm going to write the equation of the exponential. Now, does it give me the y-intercept? Yes. That's it, x equals 0. So that y-intercept is 2. Yesterday, I suggested a method for when you're given points or a table to find the growth rate. What was that method?
Divide, I don't know how to explain it. Like you divide 2 by 1/2.
Yeah, so, okay, I'm going to use 8 because then I get 2 whole numbers. If I start with 8, what am I going to divide 8 by? 2, the one in front of it. And that gives me 4. 4 is my growth rate. Now you can check it by saying, okay, what's 8 times 4? 32. That was the next number, right? So I find the growth rate by taking one of the y values and dividing it by the y value in front. And that's my growth rate. So what is the equation here? Times 4 to the x. Okay, so you look at the title of the notes, and it says writing the equation of an exponential, and you're like, but didn't I just do that? Kind of. I mean, we did. Not a kind of. We did write the equation. But here's where this is different from what we're going to do today. Here in part C, when I wrote the equation, all these x values that you're given, they're consecutive. 0, 1, 2, 3. So since they're right next to each other, it's really easy to find that ratio or the growth rate. When we look at the next problem, I'm giving you the x of 0 and the x of 2. Those aren't consecutive, so I can't just divide this time and find the ratio. I have to do some different. So we're going to start simple. We'll start in like every little step will get incrementally more challenging. So we know 0, 5. What feature of the graph is that? The y-intercept. Okay, so that is nice if I give you the y-intercept, because what part of this exponential equation does that give you? No, not B, it's A. A is starting value, it's y-intercept. We are on a roll today. Alright, so if I give you A, that means you just have to find the value of B. Alright, so let's use a similar process to what we did up above with the line. Let's see. I know this 5 here, that's the A. I don't know where I wrote X and Y up there. I don't know. I meant X and X, but that's fine. Anyways, sorry. I'm on a roll today too, I guess. Alright, 5 is my A. This 2 and 20 are an X and Y. So I'm going to substitute those values into this exponential equation. So I'll write 20 equals, I know my A is 5 times B, which I don't know, to the X. And then I just solve for B. So I would divide by 5. What happens when I divide by 5? Yeah, 4 equals B squared, and then I take the square root. What's the square root of B? Or, no, square root of 4. Oh, it's 2. Now, technically, when you divide, how many answers are there? 2. Technically, it's a plus or minus. Now, have you ever seen an exponential equation that would be y equals 5 times negative 2 to the x? No. I haven't seen anything like that. So what we're going to look at in our class is where these b values are greater than 0. We don't want the negative ones. So you can just automatically assume it's going to be a positive 2, and you don't have to put a plus sign, but it'll just be 5 times 2 to the x. Would that be exponential growth or decay? Growth, because the 2 is greater than 1. All right, next one. Same kind of thing. I'm just going to remind you how to do something in your calculator on this one. I have 0, 400, and 425. Do I give you the y-intercept? Yes, so that 400 is the A, and then I have 4 of x, and the 25 is my y. So let's put these into the expression. I'll have 25 equals, 400. I don't know my b, to the 4th power. So I need to divide by 400. Can anyone tell me what 25 divided by 400 is? 0.0625. Now, do you remember how to take the 4th root in your calculator? Yes? If you don't, I'll show you here. But we're going to take the 4th root of both sides. So if you don't remember how to take the 4th root, in your calculator, you have to type the number 4 first. So you do 4, and then the root, you go to math, and which option do you choose? 5. When I hit number 5, it turns that 4 into a 4th root. Now 0.0625. Enter. And I get an answer of 1/2. And we'll do enough different roots today that we'll catch that if you need more help with that. Alright, so 0.5 is my B. So how do I write the equation? Y equals, what was my A? 400 times 0.5 or 1/2, however you want to write it, to the x. The x is an x. And is that growth or decay? Decay. All right. I want you to try the next one on your own. You're given a graph, 2 points. I want you to determine what the equation. So what are you getting for B? 1. What do we get? 1.5, 3/2, yeah. So you can either write that as 3/2 or 1.5. Either one is fine. So your equation will be y equals what? 4? Yep, 1.5 to the x. All right, are we good there? So I gave you the y-intercept, the point. You can write the equation. Pretty simple. The only difference on these next couple is that this time one of the x's is negative, and that's going to change. We just have to be a little bit more careful and intentional with how we solve. So same kind of thing. I know my x, I know my y, I know my value of a. So let's set this up. I'll take 640 for y equals 80 times b to the negative third. All right, what do I do first? Divide by 80. What is 640 divided by 80? 8. So 8 equals b to the negative third. Oh, what do we know about negative exponents?
It's not gonna
It becomes a fraction, right? Yeah, what fraction? 1 over b to the third. Now, there are a couple different methods we can go about here to solve that. What do you guys think? Well, what's the easiest way? Like, what's coming to your head to solve that for b? Do you want the b in the denominator? No, so how do I move it out of the denominator? Multiply it. So let's multiply both sides by b cubed. That'll give me b cubed times 8 equals 1, and then I have to do what? Divide by 8. On the next one, we'll shortcut this. Those 8's go away. So I get b cubed equals 1/8, and then I take the cube root. Now, if you know your powers like you're supposed to, you don't even need your calculator for that one. What's the cube root of 1? What's the cube root of 8? 2. There's your b. There, so I have my b. So what's my final equation? Y equals, I don't remember, what was it? 80 times 1/2 to the x. All right. Okay. Let's shortcut the next one with the algebra so we don't have as much writing to do. Because what do you notice happens here? So I'm looking at, I'm going to try to isolate, let's see, this step, like this b cubed equals 1 over 8, and the 8 equals 1 over b cubed. And there's a lot of other algebra around it, but what do you notice happens between those two steps? What happened with the 8 and the b cubed? They just swapped locations, right? Because when I like multiply and then divide by the other thing, these just swap. So let's use that idea in the next one to make the solving a little bit faster. Okay, so I know my a is 2. So last one like this, and we'll change it up. So I'm going to have my 0.125, that's my y, equals a b to the negative 4. So first thing I have to do is divide by 2. And what's 0.125 divided by 2? 0.0625. And then I'll rewrite b to the negative 4th is, 1 over b to the 4th. All right, now, we can shortcut this, we said. How can I rewrite that? If I were to solve this, multiply by b to the 4th and divide, what would my actual thing be? B to the 4th equals, yeah, we'll just use a decimal, it's okay. We're going to have decimals in our fractions in this unit for some of the time. That'll be okay. We'll get used to it. Then I just take the 4th root. So can you take the 4th root of 1 over 0.0625? What is it? The 4th root of 1 divided by 0.0625. It's actually a really nice number. It's not 0.5.
It's 2.
It's 2. The 5th root of 1 divided by 0.0625. That's why make your calculator do the heavy hitting. Is 2. So what's the equation here? Y equals 2. All right. Good. All right. So those haven't been hard. I've given you the y-intercept. So it's been kind of like half work, just a little bit of algebra. Bless you. Now the next one here, I don't give you the y-intercept, do I? So now I don't give you A, and I also don't give you B. So this is where we have to figure out, I'll give you some steps, how are we going to do this? So step 1 says, we are going to substitute the values of all these x's and y's into our general exponential format. Okay? So what this is going to look like, I'm going to take this 2, 4, and I'm going to write an exponential equation that looks like 4 equals, I don't know A, I don't know B, but I know X. So I put X and Y in. So what will this other point look like when I do the same thing? A times B to the third. Okay, so now I have 2 exponential equations. And you, bless you, back in algebra 1, when you had more than one linear equation at a time, we called that a system. This is a system of exponential equations. Now, when you solve linear equations, you either solve by graphing, you solve by substitution, or you solve by elimination. Do you remember those? A little bit. Like, you might not be able to do it right now, but the words sound familiar. We're going to do something similar here, but it won't be that bad. So the next thing I want you to do is we're going to take these equations, and my suggestion is I will stack them. All right, one on top of another. And my hint to you, I even said this right here, is to put the equation with the higher exponent on top. So I'm going to write it this way. 16 equals A times B to the third. And I'm going to write the other guy right underneath. 4 equals A times B to the second. There's my system. I need to solve it. What do you think we should do? Divide. I'm going to divide the top equation by the bottom equation. And the nice thing is, when I divide there, something good is going to happen. What's 16 divided by 4? 4. What happens to the A's? They go away. And then B cubed divided by B squared is B. Nice, I got B. Do I know A yet? No, but I know B. So I know my equation will be y equals A something times 4 to the x. So at least just need the a. So what we're going to do is very similar to what we did at the top of the page, or the front of the other page. Plug that along with one of your points in. Which point do you like better? 2, 4. Okay, so let's use 2, 4. And this B in our general exponential equation to solve for A. So my y will be a 4 equals, I don't know A, but I do know I have 4 to the second. Okay? So I just simplified. 4 equals A times 16, that's 4 squared. And then when I divide by 16, what's my A equal? 1/4. I can pop that in my equation. I'll do it this way. 1/4 times 4 dx. Is that growth or decay? Growth. And don't get tricked. This is the y-intercept. The 4 is the growth rate, so that's bigger than 1. Okay? Now that one wasn't too bad, especially because when I took the exponent of 3 minus 2, I got me an exponent of 1 because those were consecutive ordered pairs, 2 and 3 for x's. Let's skip the next one. Let's skip A, because again, this has consecutive 3 and 4 exponents. I want to do ones that aren't consecutive. So this time I have negative 2 and 3. Also, I threw a negative in there. So I'm going to do the same thing. I'm going to set up a system. Now, which x value is bigger? 3. So I'm going to use this point in the top equation because it's going to have a higher exponent. So I'll write this as 10 equals A times B to the third. Right? Remember, I'm writing my system. I don't know the parameters A and B. So my second equation, I'll do the same thing. 320 equals A times B to the negative second. I'm going to put the higher exponent on top. Now I'm going to do the same process. I'm going to divide here. You're going to need your calculator probably for this one. 10 divided by 32.
32.
Yeah. 320, sorry. I was close. 10 divided by 320. Gives me a yucky decimal. Does that turn into a nice fraction? Let's see. Yeah. Let's use 1 over 32. It's just a little bit more concise. So we'll have 1 over 32. Now still, the nice thing here happens. The A's cancel. What happens to my B's? When I divide, b cubed divided by b squared, that'll be b to the 5th. You subtract your x, 3 minus negative 2. So now you have to take the 5th root of both sides. Now again, you can use your calculator, but if you know your powers, it should be easy. What's the 5th root of 1? 1. What's the 5th root of 32? 2. So 1/2. That's a nice number. All right, so then I just have to find A. Which point do you want to use? 310. Okay, so when I write my equation, I'll put the 10 in for y equals, I don't know A, but I know B is 1/2 cubed. Now, what is 1/2 cubed? What's 1 cubed? 2 cubed? 8. All right, then what's the last step? I'm going to multiply by 8 or divide by 1/8. It doesn't matter. So my starting value is 80. So I know my B and I know my A. I write my equation, which I'll just write it over here so I have more room. Y equals 80 times 1/2 to the x. Is that growth or decay? All right, let's do one more. One more, then we're done. 1, 6, and 3, 13.5. All right, which one do I need to write on the top? 3 and 13.5. All right, so I write my system. My y equals the a times b to the x power. And then the next one is 6 equals a times b to the 1st. All right, when I divide, can someone tell me what's 13.5 divided by 6? 2.25. Yeah, let's write it as a decimal for this one. 2.2, or you can do a fraction, it really doesn't matter. All right, the a's cross off, and what happens to my b's? B squared. Then I take a square root. What's b? 1.5. All right, not a bad number there. Now, which ordered pair do you like better to solve for a? I would use 1, 6. I think that's a better one. No decimal. So, right, 6 equals a times my b to the 1st. So I don't even have to do any exponents because anything to the 1st is itself. So I divide by 1.6. What's a? Cool. I have a, I have b. My final answer is 4 times 1.5 to the x. Not bad? Do you think this is easier, harder, about the same as doing like elimination substitution for lines?
Easier.
A little bit easier, right? And we're going to see later in this unit, we're going to do, or not, sorry, next unit, we're going to do a bunch of linear and exponential stuff. And the exponential just seems to be easier for whatever reason. You have 3 problems for homework practice. We're going to